There's a powder that costs less than $1. You can find it in the pharmacy aisle of any grocery store in America. It comes in a simple bag or carton. Most people use it for sore muscles and bath soaks. But when you dissolve this powder in hot distilled water and introduce it into a dead car battery, something happens that the battery industry has spent decades trying to keep quiet. The battery comes back. Not partially, not temporarily. The dead cells that a mechanic would tell you require a $200 replacement begin to function again. The sulfation crystals that choke the lead plates dissolve. Electrical resistance drops. Voltage climbs. And a battery that was destined for the recycling bin starts cranking an engine like it just rolled off the assembly line. The powder is magnesium sulfate. You know it as Epsom salt. And the reason you have never heard of this trick is not because it does not work. It is because it works too well. Then someone in a corporate boardroom did the math. The global lead acid battery market generates over $45 billion every single year. The automotive battery replacement segment alone accounts for more than $25 billion of that. A $1 bag of Epsom salt that can reverse the primary cause of battery death is not a product improvement. It is a revenue extinction event. And what threatens recurring revenue does not get promoted. It gets erased from public memory. Welcome to Forbidden Knowledge. If these stories matter to you, hit subscribe and the bell icon right now. This is where we dig up what industries spent decades trying to bury. And today, we are cracking open the chemistry behind a dead battery resurrection that costs less than a cup of coffee. Let us start at the beginning. The lead acid battery is the oldest rechargeable battery technology on Earth. It was invented in 1859 by French physicist Gaston Planté. His design used two lead plates submerged in sulfuric acid. When charged, the plates converted into lead dioxide and pure lead. When discharged, the chemical reaction reversed and the plates gradually became coated in lead sulfate. This was normal. This was the cycle. Charge and discharge, back and forth. For over 165 years, every car, truck, boat, tractor, and backup power system on the planet has relied on this exact chemistry. But here is what Planté also observed. If a battery was left discharged for too long, or repeatedly undercharged, the lead sulfate crystals on the plates began to harden. They grew larger. They became dense and crystalline. And once hardened, they stopped participating in the chemical cycle. The plate surface area decreased. Internal resistance increased. The battery lost capacity. Eventually, it could not hold enough charge to start an engine. Mechanics called it a dead battery. Chemists called it sulfation. And sulfation is responsible for approximately 80% of all lead-acid battery failures worldwide. Not cracked cases, not manufacturing defects, sulfation. A reversible chemical condition that the industry treats as a death sentence. The ancient world did not have lead-acid batteries, but the understanding of sulfate chemistry and mineral dissolution goes back centuries. Epsom salt was first discovered in 1618 in the town of Epsom in Surrey, England, when a local farmer noticed that his cows refused to drink from a particular spring. The water tasted bitter. When the water evaporated, it left behind white crystalline deposits. Those deposits were magnesium sulfate. By the 1700s, Epsom salt had become one of the most widely used mineral compounds in Europe. Physicians prescribed it internally as a laxative. Farmers used it to supplement magnesium-deficient soil. Textile workers used it in dyeing processes. And chemists recognized its remarkable ability to dissolve and displace other sulfate compounds in solution. Now let me explain exactly why Epsom salt works on dead batteries, because this is real chemistry, not internet folklore. When a lead-acid battery sulfates, the lead plates become coated with lead sulfate crystals. The chemical formula is PbSO4. These crystals are hard and electrically insulating. They block the interaction between the lead plates and the sulfuric acid electrolyte. The battery cannot charge or discharge properly because the reactive surface area has been sealed off. When you dissolve magnesium sulfate in warm distilled water and introduce it into the battery cells, the magnesium ions compete with the lead ions for the sulfate groups. Magnesium has a higher affinity for sulfate in solution than crystallized lead sulfate does in its hardened form. The magnesium sulfate effectively softens and begins to dissolve the lead sulfate crystals, freeing the lead plate surface underneath. Additionally, the magnesium sulfate increases the conductivity of the electrolyte solution, reducing internal resistance. The battery's plates are re-exposed to active electrolyte. The charge-discharge cycle can resume. This is not magic. It is called ionic displacement, and it has been documented in electrochemistry textbooks for over a century. Before I go further, let me be direct with you. This video is the overview, but the vault contains the complete protocol. Inside, you will find the exact Epsom salt to distilled water ratio for every common battery size, from motorcycle batteries to deep cycle marine units. The step-by-step cell injection procedure with safety precautions for handling sulfuric acid. The slow charge recovery protocol that maximizes plate restoration after treatment. A diagnostic chart to determine whether your battery is sulfated or has a dead cell which requires a completely different approach. and the maintenance schedule that can extend a lead-acid battery's life by 3 to 5 years using periodic Epsom salt treatments. The link is in the description. But stay right here, because the next part is what the battery industry does not want in your search results. The military has known about electrolyte reconditioning for decades. During World War II, the United States military operated millions of vehicles across multiple theaters of war. Lead-acid batteries powered everything from jeeps to submarines to field radio systems. Replacement batteries were heavy, expensive, and difficult to ship to forward positions. The Army Signal Corps developed field maintenance protocols that included electrolyte supplementation and sulfation treatment procedures. Technical manuals from the 1940s document the use of various sulfate compounds to restore battery function in the field. The concept was simple. It is cheaper and faster to restore a battery than to ship a new one across an ocean. After the war, NASA continued research into lead-acid battery maintenance for ground support equipment and early space program power systems. Studies conducted at military research facilities confirmed that sulfation was the primary mode of failure and that chemical treatment could reverse early to moderate sulfation in a significant percentage of cases. So why does the average car owner not know this? Because the business model depends on your ignorance. The battery replacement cycle is one of the most profitable recurring revenue streams in the automotive industry. The average car battery costs between $100 and $250. Most last 3 to 5 years before sulfation kills them. That means the average driver spends between $500 and $1,500 on batteries over the life of a vehicle. Multiply that by 280 million registered vehicles in the United States alone, and you have a replacement market worth tens of billions annually. AutoZone. O'Reilly? Interstate Batteries? Every parts store in America profits from the assumption that a dead battery is a dead battery. A $1 bag of Epsom salt that reverses sulfation and extends battery life by years does not fit that model. It cannot be patented. It cannot be branded. It cannot generate a service contract. And what cannot be monetized cannot be allowed to become common knowledge. If you have made it this far, you already understand more about battery chemistry than 99% of car owners and most mechanics. Hit subscribe and share this video right now. Every share puts this knowledge back into circulation. Now here is the exact procedure. This is the part you save. Step 1, buy Epsom salt. Magnesium sulfate is available at any pharmacy or grocery store. A 1-pound bag costs about $1. Step 2, test your battery. Use a multimeter. If the voltage reads below 10, 5 volts under load, or the battery will not hold a charge, after a full charge cycle, it is likely sulfated. If the voltage reads 0 on 1 or more cells, the battery may have a physical short, and this treatment will not help. Step 3, put on safety glasses and rubber gloves. You will be working near sulfuric acid. This is not optional. Step 4, remove the cell caps from the top of the battery. If your battery is sealed, use a small drill bit to carefully open the cell access points. Step 5, dissolve 7 tablespoons of Epsom salt in approximately 1 quart of warm distilled water. Stir until fully dissolved. Do not use tap water. The minerals in tap water will contaminate the cells. Step 6, using a plastic funnel or syringe, carefully add the Epsom salt solution to each cell until the plates are just covered. Do not overfill. Step 7, replace the caps. Step 8, connect the battery to a slow trickle charger at 2 amps or less. Charge for 24 to 48 hours. A fast charge will not work. The slow charge allows the magnesium sulfate to gradually dissolve the sulfation crystals while the plates reactivate. Step 9, after charging, test the voltage again. A healthy 12-volt battery should read 12, 6 volts or higher with no load. Step 10, if needed, repeat the cycle once more. Some heavily sulfated batteries require 2 treatments. Total cost, under $2. Compare that to the $150 to $250 for a new battery that will sulfate and die in 3 to 5 years. I need to be honest with you. This is not a miracle, and I will not pretend it is. First, this only works on sulfated batteries. If a cell has a physical short, a cracked plate, or internal damage from overcharging Epsom salt will not fix it. Sulfation accounts for roughly 80% of failures, but the other 20% are mechanical and require replacement. Second, the treatment works best on early to moderate sulfation. A battery that has been sitting dead for 2 years with severe crystalline sulfation may only partially recover. The sooner you treat sulfation, the better the results. Third, adding Epsom salt changes the electrolyte chemistry slightly. Over time and repeated treatments, the specific gravity of the electrolyte may drift from factory specifications. This is a maintenance trade-off, not a permanent fix. Monitor your battery if you use it in a critical application. Fourth, sealed AGM and gel cell batteries are harder to treat because accessing the cells requires modification that may void any remaining warranty. This protocol works most reliably on traditional flooded lead-acid batteries with removable caps. Fifth, sulfuric acid is dangerous. If you get electrolyte on your skin, flush immediately with water. If it contacts your eyes, seek medical attention. Do not skip safety equipment. Your great-grandparents knew how to maintain a battery. Every farmer in America before 1960 kept distilled water and mineral supplements for their equipment batteries. They checked electrolyte levels monthly. They trickle-charged over winter. They understood that a battery was not disposable, it was maintainable. Then the sealed maintenance-free battery arrived in the 1970s. The marketing said you would never need to touch it again. What they meant was you would never be able to fix it again. The knowledge did not become obsolete. It became inconvenient for the companies selling replacements. There was not a better way. There was just a more expensive way. Subscribe and share this video. Every share preserves what they spent decades trying to erase. The next vault opens soon, and what is inside will change the way you look at the green streaks growing on your roof right now.